So this was by far one of the most surprising releases this year. And of course, that's pretty funny because the year has just started. Now, I'm referring to DeepSeek R1. As you can see, they tweeted, DeepSeek R1 is here. This is the model that is truly surprising because the performance is on par with OpenAI's O1. But that is not the surprising part. The surprising part about this is that this is actually a fully open source model that is available to basically everyone for free on their website. Trust me, the research surrounding this and how effective this model is truly astounding. So let's dive into exactly why the internet is actually raving about this. This is something that I would say caught OpenAI by surprise and truly shows where the AI industry is headed as a whole in terms of how quickly these models are getting better. This bar chart diagram that you can all see right here basically shows you why this model has been all over the internet recently. This is the DeepSeek R1 model, which is a direct competitor to OpenAI's O1 model. Both of these models are based around System 2 thinking, which is essentially where these models think for longer. It's a new concept that we've only recently started to explore. But as you can all see, this is something that is yielding outstanding results across the board for any models developed in this way. Now, most surprisingly, it's incredible because the current available models, if we're looking at whichever models are currently the best in terms of performance, most people would say it's OpenAI. But now, somehow, China has managed to somewhat outshine the master in AI or the leaders in innovation by releasing such a powerful system. You can see here that the DeepSeek R1, represented in the striped purple-blue bar, is right on par with OpenAI's O1. And of course, it exceeds OpenAI's O1 Mini in a variety of different benchmarks. Now, you have to understand that a lot of these benchmarks are really difficult. I would even argue that some of these are potentially completed, considering that some of these benchmarks have maybe a 2 to 5% error rate. So it's quite likely that these models are remarkably effective at these tasks in ways that people can't fully understand. This is why I think the industry is starting to realize that if we get these kinds of performance gains from AI models, and we know the cycle is speeding up in terms of capabilities, where are we going to be in 3 years perhaps? Now, this is pretty crazy because a lot of people who are excited about R1 like I am too, feel this way not only because it's on par with OpenAI's O1 model, but because it is remarkably cheap. This now means that developers trying to build a product or even just using this for testing can access a state-of-the-art system for pennies on the dollar. This is going to be game-changing for the entire industry because, in a variety of use cases, we know these models are extraordinarily expensive. Now, this part right here is what I think stands out as a truly remarkable piece of innovation from this team. It's something that most people overlooked while the focus was on the R101 debate. In the research paper, they actually give us a glimpse of how the distilled models perform. For those who might not be familiar, model distillation involves having a teacher model and transferring its knowledge into smaller models, making them both smarter and more efficient. This process is, of course, driven by the need for efficiency. You essentially get the intelligence of a highly advanced model condensed into a much smaller one. As a result, you save a significant amount of time and improve inference efficiency. The astonishing thing here is that without distillation, achieving similar results with smaller models would simply not be possible. Distillation allows us to reach performance levels that were previously unattainable at smaller scales. It's an incredibly effective process. What we're seeing here is these frontier models like GPT-4, Claude 3.5, and some others performing well on various benchmarks. But what's truly surprising is the R1 model, the new offering from DeepSeek, being distilled down into a 70B model, a 32B model, and even an 8B model like Llama. In some cases, these distilled versions even surpass the larger models in specific use cases. That's incredible. Imagine achieving the performance level of something like Claude 3.5 or Sonnet in a 70B model size. That kind of breakthrough is an absolute game changer for so many people. Of course, I always recommend thoroughly testing these models on the specific benchmarks that align with your use case. Some might use them for creative writing, while others may focus on math reasoning, scientific analysis, or coding. Whatever the purpose, it's crucial to validate the models before jumping to conclusions, as certain models excel in specific areas, while others may not. That said, what we're witnessing here is absolutely remarkable. Distillation is enabling us to produce highly effective models at much smaller sizes, while still retaining the reasoning capabilities of much larger ones. I believe this will set the tone for future trends. Who knows? Maybe someday we'll have incredibly intelligent AI models that operate seamlessly on our devices. For example, GPT-4 scores around 70 on certain benchmarks and 50 on the GPQA, which is one of the toughest tests. Yet, these distilled models are achieving comparable results, all while being much smaller in size, which is truly incredible when we realize what's going on here. We do know that, as time goes on, this is quite likely to improve. Now, this wasn't the only remarkable thing that existed in this paper that most people were surprised about. One of the most remarkable things they actually talk about is the fact that there is self-evolution and the emergence of sophisticated behaviors as the test time computation increases. As you know, one of the things these models do is think for a longer period of time, and the longer they think, the better the responses get. So you can see right here that it says behaviors such as reflection, where the model revisits and reevaluates its previous steps, and the exploration of alternative approaches to problem solving arise spontaneously. What's interesting is that these behaviors are not explicitly programmed, but instead emerge as a result of the model's interaction with the reinforcement learning environment. This spontaneous development significantly enhances the model's reasoning capabilities, enabling it to tackle more challenging tasks with greater efficiency and accuracy. Essentially, what they're stating here is that because the model is thinking for so long, oftentimes during those reasoning thought processes, it might come up with innovative ways to solve the problem. This is something emergent in this system because they didn't explicitly train it to do that. So this is actually an example of this in practice. You can see right here, the model is reasoning through this math equation, thinking about how it can solve it. The bit they've highlighted here says, wait. That's an aha moment. I can actually flag here. This is something super surprising because this is where the model learns to rethink using an anthropomorphic tone. One of the things most people have noticed about this DeepSeek R1 model is that it actually thinks somewhat like a human. It's weird. You're essentially hearing the internal thoughts of an AI model reasoning through certain problems. Surprisingly, it managed to say, wait, aha! I can actually flag this here and solve the problem better. I'm going to show you another example of this, which is just absolutely incredible. This is where we have one user on Twitter sharing the internal thought process when they prompted the model to think of a random number. You can see, if you read this in detail, the model comes across as if it were a human thinking. For example, if I were reading this, I'd say, yep, that sounds like a person trying to figure out a random number. You can see how it says the user wants it to think of a number between 1 and 10,000, but not reveal it. They mention not to overthink, so maybe it should just pick a number quickly. Let's see, 777 might come to mind, but that feels too obvious. Then there's 1, 2, 3, 4. No, that's too sequential. Maybe it could choose a number that's common but not too predictable, like 42, a nod to Hitchhiker's Guide to the Galaxy. Alternatively, it might think of 2004, or no, maybe 18765. Oh wait, that's from a song! The fascinating thing about this is that we've never really had insight into the internal reasoning of OpenAI's models before. Historically, they've kept that hidden, understandably so, given the need to protect their advanced reasoning methods from competitors. But what if the real reason is that these models often think in ways that seem remarkably human? That realization could lead us to anthropomorphize them, essentially start treating them as though they're truly human. This ties into ongoing debates about consciousness in AI. To see the internal thoughts of a model is both surprising and revealing. Take this example. The model says, want to be anthropomorphized? Give me a single word answer. It then reflects, I first need to understand what this means. Given that I'm an AI, I don't actually have personal desires. If I say yes, it might reinforce this idea. It's something people need to be aware of because this will spark heated debates as these systems become more intelligent. The reason many are so bullish about this technology is that moments like these are not just aha moments for the models, but also for the researchers studying their behavior. These instances highlight the power and elegance of reinforcement learning. Instead of explicitly teaching the model how to solve a problem, you simply provide the right incentives, and it autonomously develops advanced problem-solving strategies. This aha moment serves as a powerful reminder of reinforcement learning's potential to unlock new levels of intelligence in AI systems. It's paving the way for more autonomous and adaptive models in the future. If you're unfamiliar with reinforcement learning, I may include a brief explanation of what it is. Essentially, reinforcement learning involves where you reinforce the good behaviors, and over time, when it's constrained to an environment or a set of rules, these emerging capabilities spawn in. Usually, they are basically magic in the sense that you couldn't have predicted them before, and they typically allow the AI to do something crazy. Now, if you want to take a look at the full R1 evaluation, you can see right here how the model looks in terms of comparisons to other models like Claude 3.5, Sonnet GPT-40, the DeepSeek V3 base model that they released before, Zero 1 Mini, and Zo 1. We can see that this model is definitely up there in terms of its capabilities. Again, if we look at the distilled model evaluation, we can see that these models also perform exceedingly well on a variety of different benchmarks. Now, the craziest thing about this all is that someone asked on Twitter, how is DeepSeek going to make money? Someone actually responded that DeepSeek's holding is a quant company. Many years ago, these were just super smart guys with top math backgrounds who happened to own a lot of GPU SL trading equipment for mining purposes. DeepSeek is actually their side project for squeezing those GPUs. So I think this is something absolutely incredible. This company's side project has managed to catch up to OpenAI. I'm actually wondering how much longer their MOE may last. Overall, it seems to be an exciting time to be in the AI industry, as there are non-stop updates with regards to how smart these models are.